Okay, so we are talking about push down automata. We have discussed the what do you mean by acceptance language accepted by push down automata. So, suppose we have given a push down automata M, which is q delta q 0 and z 0, then f. We know all these terms. The q is the set of states, and this is the say input alphabet which is written on the tape, and this is the symbol stack symbols. These are all finite, and this is the delta. Delta is a function from q cross sigma. We do have a epsilon move. This is a NFA, a non-deterministic PDA, and we have a stack symbol, and it is going to some 2 to the power q and the stack symbol. So, that means given a, so suppose this is our A, and if we are at state q, so delta of q comma A comma z. So, z is the top of the stack. So, top of the stack and input tape, this is the input tape, and this is the stack, and stack symbol is initialized by z 0 and initial starting state is q 0. Now, depending on this current state and the input, it could be epsilon also, input alphabet, and the top of the stack symbol, it will go to some of the states. Since it is a epsilon non-deterministic move, so we may have many options. I mean, so it can go to some p 1 gamma 1 dot 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 p k p k gamma k, like this. Okay. So, this is the and then we have seen the we have defined the ID, instantaneous description. So, if we have to, if the input string is w, which is say A1 A2 AN, then the initial ID is initially our state is q 0 and w is the input. So, this is the tape is A1 A2 AN, which we have to read, and initially it is q 0 and top of the stack is z 0. This is the stack. So, stack is pointing here, and this is the situation. This is the initial ID. So, w, and then we have z 0. And if the several iteration, we know the move relation, depending on the delta, we have a next state and next. So, this stack will be z 0 will be replaced by some. So, this way if you continue, and if this is going to in the move relation, more maybe one or more relations, more application of the transitions rule. If this is going to some q f and epsilon, and we do not care about this final. So, this set of w, which is having this, where q f is some final state. Then we call this is the language accepted by final state. So, this is we defined as L of n. This is language accepted by the final state. Similarly, language accepted by the empty empty stack, we have defined like this. This is set of all strings, which is starting with this, and which is going to empty stack. I mean, here we do not care about the final state. So, empty stack means, so q, so we do not care about the which state we are in p, but epsilon we exhaust the tape, and then the stack must be empty. Then this is called the string accepted by w is the string accepted by the empty stack, and this collection of all such string is denoted by the language which is accepted by the empty stack. Now, we will see the equivalence between these two. I mean, they are basically equivalent. Language accepted, if we have a PDA which is giving a language accepted by the empty stack, then we have a corresponding PDA we can construct, which will give us the language, which will accept the same language accepted by the means of final state. And then we will see these are basically giving us the context free language CFL. Okay, so let us first show the equivalency between these two acceptance. So, first we will show the language accepted by a empty stack is same as language accepted by a PDA. So, before that let us take a example. Okay, we will take the example together with that. So, this is telling let L be a language, L is a subset of L be a language such that L is, that means we have a L is a language accepted by empty stack corresponding to the PDA M1, where M1 is some Q1. So, this will be same because we are accepting the language. So, Q the sigma input alphabet we are not changing. So, let me write the M1 here. State maybe we can change. Okay, M1 or for M we can just have the no subscription sigma delta and say Q0 Z0 and we can say phi, because this is the M1 is the language accepted by the empty stack. So, we do not really care about the final states, there may not be any final state, because this is the language accepted by the empty stack. Okay. After reading the string we must I mean our stack should be empty, that is the language accepted by the empty stack. Okay. So, now suppose this is accepting this language L, which is a collection of the string coming from the input alphabet. Now, you have to construct a M2, then there exists some M2, this is the theorem, some M2 such that M2 the PDA, there exists some M2 the PDA push down automata M2 such that the language accepted by this M2 in the means of final state accepted by final state is same as this L, which is same as L. So, basically we need to show there exists a M2 which will be coming from this M1, we need to construct a M2 and they should give us the same language. So, that we have to prove. So, let us try to prove that, let us try to construct the M2 given M1. So, so the idea is, so this M1 is telling, M1 is accepting all the, this is the proof sketch we will give. So, what is the idea? Idea is we are, so if W belongs to L, then for this string W, what we are doing? We are just starting with this Q0, then W Z0 and it is end up with after this is the move relation, after repetition of application of this delta, it will go to some state P and then epsilon and this is also epsilon. Okay. P is any state, we do not have any final state over here. So, P is any state. So, that is the W. Now, we want to have construct a M2 which will accept this W in the means of final state. So, for that what we do? Let us construct M2. M2 will be state will be, we have to have, we are taking two new states, one is for final state. So, Q0 prime and say QF, this is the state and we have sigma and this we are using a another say stack symbol which is the x 0, that we are going to use for the initial stack symbol for this new DFA, even for this new PDA. Okay. And we need to define the delta hat, that will be the change delta, and q 0 prime is the new final state, and x 0 is the this one, the new initial stack symbol, and we have QF. QF is the final. So, this is our Q, this is our M2. So, M2 consists of all the states of M1 along with 2 new states, and this Q0 we are Q0 prime we are going to use for the new starting state for this new automata, and QF we are going to use for the final state, this is our F, and this will be remain same, and here the stack symbol, it will be all the stack symbol of the M1 along with a new symbol x 0. So, x 0 we are going to use for the new initial stack symbol for this PDA, and delta prime we need to define. So, how to define delta prime? So, let us try that. So, this I will come back. So, this is the this one. So, let us define delta prime. So, this is the rule. So, delta prime of, so initially q 0 prime is the first one with the epsilon move, and our initial stack symbol is z 0, sorry, for M2, for M1 it is z 0, but for M2 we want to put x 0 over there. So, initially we are at q 0 prime, with this what we want to do? We want to go to q 0 with the new. So, this is nothing but q 0, q 0 is nothing but, so we have M1, let me write the M1 is q delta q 0 z 0 phi. So, this was the initial this. So, so q 0 is the state for the starting state for M1. So, q 0 along with, so what we do, we replace this by x 0 z 0, we replace this by sorry z 0 x 0. So, now it is z 0, and now we are at the initial state of M1, and then we will follow the rule of M1. Okay. Then we will follow the rule of M1, transition rule of M1. So, that is there. So, q a z, which is same as delta of q is in this M1 z, and this is true for all q belongs to q and all a belongs to, it could be epsilon also, and for all z is the symbol coming from M2. So, this is basically rules of M2. So, after we assign this, then we will follow the rule. We are at our state is at q 0. After we assign this, now we are following the rules of M1, and once we follow the rules of M1, if it is if W has to accept, then W will end up, this is the, if W is a accepted string, this is A1, A2, AN, if this is W, if W is the accepted string, so it will end up with, this will be empty. So, that means x 0 will be there remaining, and this does not matter, this will go to any state and it will end up. So, that string we have to accept in the sense of final state. So, that we are going to do now. So, this is the R3. So, once we finish up this, that reading a, once we finish up this epsilon, and if we see a q 0 over x 0 over here, that means this is gone and this is q. So, this contains q 0 comma epsilon for all q belongs to q. This is the rule. Okay. This is for all q belongs to q. So, that means if a w, if we are starting with a w, so q 0 is the starting state for this m 1, q 0 w and then z 0, and if w is belongs to L of m 1 n of m 1, then it will end up with what? It will end up with some state, we do not care about that, because this is accepted by the empty string and this will be empty and this will be empty. Now, once this is empty, so it will be for new PDA, it will be remain x 0. Okay. Then we have to put it to the final state. So, that means this should contain, once we reach there, we should have a move which will reach us to a final state of the new automata. Okay. Because it may happen that before that we may halt. So, that is why it is containing, it contains this. So, it is not always it is unique, like before that it may halt, that means then our stack may be empty before that, then we have to halt there, we have to, so this branch will not end up with that, because we may have many other variable to read there, many other input to read there. Okay. So, this is the idea. So, once we reach to this epsilon, that means x 0 this will be vanish, then the x 0 will be remaining. So, then if our string is, then we should have an option to go to the final state, because if the string is empty, then it must accept that string. So, that is why this is the rule, this contain this. Okay. Even we could put here something like gamma, because in this case we are only concerned we should reach to a final state. So, instead of epsilon we can put gamma over here. Anyway, we will take an example, then it will be more clear. So, this is the idea. So, we introduce two new states along with a new stack symbol which is initialized in the stack, and then we have a final state like this. Okay. So, let us take an example. So, let us take a PDA which is accepting the some language. So, in the means of empty stack. Okay, let us consider a PDA like this. So, this is q 0, q 1, a b, we have only two stack symbol 0 and sorry, it is not 0, this is a and z 0, and we have delta q 0, z 0 and phi, q 0, z 0, phi. Okay. Now, let us define the delta. So, delta is as follows, this is our m 1. So, this is we want to accept the language like a to the power n, b to the power n. So, delta of q 0 a. So, once we have a, so this is the starting one. Once we have a, what we will do? We will push a into the stack. So, this is belonging. So, we will be at q 0 and we push a into the stack. So, like this. So, this is our sorry. So, this is the stack which is initialized by Z 0. Now, if the input tape is say like this A. So, what we do? We push this on A on the stack, and when we see a B, we will pop it from the stack. So, this is one rule, delta of Q 0 A again we will push this into the stack. So, Q 0 A R 3 delta of Q 0 B A. So, it will erase it will pop A. So, that means it will erase. So, this will go to Q 1 and it will erase A. Q 4. So, now Q 1 B A. Now, if we see A in Q 1, so again it will erase that, but it will be remain at Q 1. And the last one is delta of Q 1 epsilon Z 0. So, this will be Q 1 epsilon. Okay. So, if you draw it, it will be like this. Let me draw this. So, we have two states Q 0 and Q 1. This is the starting state, and with Q 0, so with Q 0, if we see A and if Z 0 is the stack symbol, then it will be replaced by A Z 0. And if we see A again, and if the stack symbol is A, then it will be A. So, we are pushing A, and if we see a B, then it will go here. If we see a B and the stack symbol is A, then it will erase A. And once we reach B like Q 1, then if we see a B and if the stack is A, it will erase A. And if we see a epsilon there, and if the stack is Z 0, then it will erase Z 0. Okay. So, this is the transition functions of this. Now, what it is accepting? So, this is by empty stack. So, that is why we do not have any final state over here, final state is empty. So, what it is accepting? So, how to determine? We have to determine in of M1. So, language accepting. So, this is the set of all W such that if you start with Q 0 with this W with Z 0, this must go to some of the state, we do not care about that, but we must end up with reading the string and it must go to the, it must erase all the symbol from the stack. So, we have to find this. So, let us find this. So, this is the automata we have. So, our claim is this will be we are claiming that this n of M1, this will be a to the power n, b to the power n, where n is greater than 1. Okay. So, this we have to show. So, for that what we can do? We can just Yeah. So, we have to show this that it is just taking the a to the power n, b to the power n. So, basically the idea is, so whenever we see a 1, so that means if we start with say a b say. So, if we are q 0, so this is the suppose our w is a b. So, what we do? We just put a stack symbol z 0 and our initial this is q 0 and our tape is a b. Now, what is the next step? Now, we are seeing a and stack is z 0. So, it will be going to, so this ID, so q 0, then a b and z 0. So, this is going to where? This is going to, so the stack will be like this. So, it will be z 0 a. So, if we see a in the input, it will push a symbol there, and if we see a b, then it will pop. So, that means that because we have to count the number of a's, number of b's. So, that is the way we can count. So, then it will go to again q 0 and the stack symbol is, this is the b you have to read, and this z 0 will be replaced by a z 0. Now, once we see a b, then it will be q 0 to b. So, if it is a b, it is going to q 1. So, q 1, so this will go to q 1 and this is empty, and we have to pop erase a. So, that is z 0. Now, in here if we see a z 0 this, then it will just make it empty. So, it is q 1 and this empty. So, this is the accepted by the final state. So, this is accepting a b. So, in general we can show this is accept a to the power n, b to the power n, because if we just take a to the power n, b to the power n, it will just keep on pushing a until it see a b. Once it see a b, then it will keep on popping a, and so it is a count like how many times a is occur, how many times b is occur. So, when it will have a same number of push and pop, then it will be this b will vanish and it will be here, and we will see a z 0 in the final state, and then. So, eventually this is n of m 1 is nothing but a to the power n, b to the power n is greater than or equal to 1. Okay. So, this is the language accepted by empty stack. So, now we will have the corresponding language which is accepted by this final state. So, for that we can take this. So, this we have to add a new symbol. Okay, this we can erase. Okay. So, we have to find m 2. For m 2 what we are doing? We are keeping the all the states of m 1. So, all the states of m 1 along with the new starting state and the new final state, and this will be remain same, and we have a x 0 is the new initial symbol in the stack, and this is the delta hat, and q 0 prime x 0, and this is q f prime. Now, the rules is like this. So, this is the starting for m 2. We start with q 0 prime, and with the epsilon move, with the epsilon, and we see a z x 0 in the stack, because x 0 is the initial symbol in the stack for m 2. So, this will be going to x 0 sorry z 0 x 0. Now, we are here, we are at q 1. So, now it will replace by z 0 x 0. Now, z 0 is the starting symbol for m 1. So, now we have a rule for m 1. So, we have a rule for m 1. So, this is 1. So, this will go here. Yeah. So, we have a rule for m 1 like this, and then after here 1. So, this will be yeah. So, this will keep on doing this. So, this will change like this, it will be x 0. So, epsilon of yeah. So, from here then we have a q f prime, which is nothing but if we see a epsilon move and if we see a x 0 in the stack, then it will erase epsilon. So, this is the final state. Okay. So, after this we are playing with M 1. Now, if the W is accepted, the string, then that W will give us erase this and it will reach to x 0 and the input tape is finished epsilon. And then once we reach that, so that is the situation over here. Once we reach that, then we have to have another move to go to the final state, because we want to accept this as a acceptance by the final state. So, this is the one. So, in the next class we will see the converse, that the acceptance, if given a NFA which is accepted by the final state, we can have corresponding we can construct a corresponding given a PDA which is accepted by the final state, we can construct a corresponding PDA which will be accepted by the empty stack, and then we will see the equivalence between the context free language and the PDA. So, context free language will corresponding to the PDA with the empty stack. Thank you.